have you ever been in a really deep chat with an AI, and then all of a sudden it just goes off the rails? It completely forgets what you were talking about, or it gives you an answer that makes zero sense? It almost feels like the conversation itself just got sick? Well, what if we could actually treat that failure not as some random computer glitch, but as a medical condition that we can diagnose?
Right, let's get into it. This is the big question, isn't it? Why do these AI chats, which start out so smart and helpful, suddenly just fall apart at the seams? It's something we've probably all experienced, but for researchers, figuring this out is absolutely critical, especially as we start trusting these AIs with more and more important stuff.
And believe me, the stakes can get incredibly high. Just imagine you're talking to a medical AI assistant. The research this explainer is based on uses this exact scenario. At first, it's giving you great, accurate information. But you keep probing, asking more questions, and then it starts to get shaky until it gives you advice that completely contradicts what it said 5 minutes ago. Now, in that kind of situation, a failure isn't just a little annoying, it's downright dangerous.
So, researchers had this brilliant idea. Let's approach this problem like doctors trying to diagnose a patient. They started treating a conversational failure like a medical event, and their goal was to find the symptoms, the warning signs, that could predict when it was about to happen.
This brings up a really key point. Not all topic changes are created equal. You've got what they call abrupt drift. These are the sudden, jarring topic shifts that give you whiplash and break the whole flow. But then there's gradual drift, where the conversation evolves slowly, naturally from one topic to the next. The mystery for the researchers was, which one of these is the symptom of the sickness and which one is just the sign of a healthy, normal conversation?
Now, to figure this out, they didn't have to invent some brand new technology. Instead, they borrowed a really powerful diagnostic tool that's been a staple in medical research for decades, used to figure out patient outcomes.
It's called survival analysis. And yeah, the name sounds a little intense, but the idea is actually pretty straightforward. In medicine, doctors use it to predict, say, how long a patient might remain disease-free based on certain risk factors. So these researchers thought, hey, what if we use that same logic for AI? Could they predict how long a conversation would survive before it failed just by looking at its symptoms?
And here's exactly how they did it, looking at almost 37,000 conversation turns. First, they had to define failure. For them, that was the very first time the AI gave a wrong or inconsistent answer. Simple enough. Second, time was just the number of back and forths you had with the bot. And third, and this is the important part, they identified the risk factors, the specific conversational patterns that might be red flags for a coming failure.
They really zeroed in on 3 main symptoms, and all of them have to do with this idea of conversational drift, or how the topic changes over time.
Okay, let's break these down. First up is prompt-to-prompt drift, P2P for short. This is that conversational whiplash I mentioned, a really sharp, sudden topic change from one turn to the very next. Then there's context-to-prompt drift, or C2P. This measures how far your latest question strays from the overall theme of the entire chat. And finally, you've got cumulative drift, which is basically the grand total of all the topic changes added up over the whole conversation. All right, so they had the symptoms lined up, and their diagnostic tool was ready to go. It was time to finally figure out what was making these AI conversations so sick. And I gotta tell you, the diagnosis was not what anyone was expecting.
So, what do you think? Before I show you the results, which one of these 3 do you think is the real conversation killer? Is it the sudden shock, the slow wandering away from the topic, or just the total amount of change over a long chat?
The data could not be clearer. Just look at that first bar. That abrupt prompt-to-prompt drift, it is absolutely catastrophic. For a top model like GPT-4o, a single sharp turn increased the risk of failure by 4.6 times. That is a huge risk factor. Drifting from the overall context was also a problem, roughly doubling the risk. But now, look at that third bar. This is the stunner. Cumulative drift, the one you might think would be bad, was actually protective.
You heard that right. It says it right here in the research. Counterintuitively, higher accumulated drift is associated with lower risk. This just turns everything we thought we knew on its head. The working theory is that if a conversation has already navigated a bunch of small, gradual topic shifts and survived, the model has kind of learned to adapt. It's actually getting more stable and robust, not less.
The researchers also made sure they were using the best possible doctor's kit for the job. They tested a few different kinds of statistical models, and these accelerated failure time, or AFT models, were the clear winners. They were just better at spotting the problem and being more accurate. Why?
because AFT models are built for situations where the risk of failure speeds up over time, which, it turns out, is a perfect description of a long AI chat that's slowly going off the rails. So, now that we have a clear diagnosis, we can finally write a prescription. And this isn't just theory. This research gives us a concrete playbook for building AI that's healthier and a whole lot more reliable.
This really lays out a path forward. We can build real-time monitoring systems, think of it like a heart rate monitor for a conversation, that watch for those dangerous P2P shocks as they happen. We can use these AFT models to create early warning systems that flag which chats are at high risk of failing. And that means we can intervene proactively. Have the AI maybe suggest a new topic, or even pass the chat to a human before it messes up and loses our trust.
So look, if you take just one thing away from all this, let it be this. A conversation that wanders isn't necessarily a bad thing. The real danger isn't that the topic changes, it's the speed of that change. It's not if it wanders, it's how fast. A slow, gentle evolution can actually be a sign of a healthy, adaptive AI. A sudden, jarring leap, that's the real symptom of sickness.
And this leaves us with one last, pretty mind-bending thought to chew on. We always demand that our AIs be perfectly, rigidly consistent. But what if this research is telling us that the healthiest, most robust conversations are the ones that are allowed to evolve and adapt? Maybe we need to totally rethink what we mean by consistency. Maybe the best AI isn't the one that never leaves a topic, but the one that knows how to wander gracefully.